I'm back with another set of top interview questions for data scientists. This is part 3. Prior to this video, I already have given to you 10 questions, 10 top interview questions. So please make sure to watch them before you watch this video. As usual, the agenda of this video is to share another 5 top interview questions with you. Along with the questions, I'm going to share strategy to answer them. In other words, the way you should approach the question or present the answer so that the interviewer understand what you're talking about and also will be confident about your knowledge about machine learning. Let's see the very first question. So the first question that you can expect would be, what is machine learning? Well, this question looks to be very straightforward, but it understand when in an interview, because this is so general question, everybody does understand. But if the interviewer is asking you this question, he is not expecting too technical answer from you. Rather, he's trying to understand, as a data scientist, can you explain machine learning to a simple non-technical guy in layman words? That's the whole idea. Because if you can explain this, what is a machine learning in layman words, you better understand it. That's the whole concept and mind game works around. So you should be able to answer this in layman words, in simple words, and that's what being expected whenever this question comes or given to you. So your answer should be very simple way, saying that machine learning is a scientific approach of making machines learn from historical data. Now, what is a machine here? So machine is nothing but the computers we are working on, any computers in this world. So whenever you try to make a computers learn out of a data, that's what it's a machine learning. Very simple naive, in words you are explaining to anybody. Okay, little technical if you want to present. Technically, machine learning is nothing but a set of algorithms in combination with the statistical concepts is your machine learning. It's not just rule-based algorithm, but it's also statistics. A lot of statistics, in fact, is around in along with the algorithm forms in machine learning. That's why to survive in or work in machine learning domain, you need to know statistics and you should be very strong with that. I hope that's clear to you. Let's see the second question. And the second question says, you have to tell the types of machine learning. Now, again, this is very typical question. You may be thinking, oh, I know this, maybe, or may not be. But it happens that a lot of the time, it's seen that candidates fail to answer these questions very fluently. I know this is very simple and anybody can answer, but it does not happen so. Mostly, the candidates are seen to answering complex questions like explaining random forest algorithm architecture or explaining deep learning. But if you ask the very basic questions, classification of machine learning, people do fail over there. And that's the reason it's very unweird, but it's true. It's true that this sort of question comes in interview, and there he's not expecting, the interviewer is not expecting any rocket science answer or any innovative answer, rather the same answer which is true but in more fluent way. How fluently you answer, with what confidence you answer, that itself builds the confidence in for the interviewer in your answer. So you should be very fluent in answering this question, and the classification goes this way. So we have two types of machine learning models, supervised and unsupervised. Supervised is further classified into classification and regression problems, and unsupervised problems are further classified into clustering, PCA, topping modeling broadly. Okay, so now that's all. If you answer with confidence, with fluency, it's sufficient. Okay, but if you think you don't know this division well, I would recommend you to basically write down, practice this 1 minute on daily basis for over a week until you become very fluent about it. That's what it's required. Okay, and along with this division or classification, if you can present some answer from each of these classes, would be again a very nice answer while answering this type. So I have got few examples for you, but you can add your own as well. So in classification problems, you can add cancer patient classification, or you can talk about eye image classification. If you're not sure what an eye image classification is, um, let me give you an idea. Like, no, let's say you have a set of eye images representing various classes, like a normal eye, a cataract eye, or a glaucoma eye, or some other diseased eye, and you have to classify. So tomorrow, if I gave you the image of my eyes, you should be able to give it to your model, and your model should be able to label it. Either it's a normal eye, or it's having some disease. That's what eye classification is here. I can leave a link on this document about eye classification if you need an example. I have a very good example. I will leave the link in the description box. You can check out. An example of the regression problem can be stock price prediction, very well known, or house price prediction, very well known. Yeah, or let's say power load prediction. So the electricity that we consume in our house, that also, if you forecast, that comes under regression. And in clustering, the example you can give like customer segmentation, very well known. Okay, so in our supermarket, different items are there, and different branches are there nowadays, like retail type, and then maybe gadgets, and then maybe some other form, right? So those customers, if you categorize or segment into various groups, that becomes your clustering. Or let's say newspaper grouping based on context. Let's say I have a various digital form of newspaper, and if you are grouping it into like business type, or domestic type, or international type, or maybe state type, so on. So that becomes your, again, it's an example of unsupervised learning, and it comes under topic modeling. Topic modeling is nothing but this grouping of the various topics based on its context. Okay, or sentiment analysis, very popular. So you take the feedbacks from others and you analyze that. That comes under sentiment analysis. Hopefully it's clear up to now for you. Let's see the third question for today. Example of classifier regression clustering algorithm. Now, this question may not come directly, but if you can give the answer while explaining these types, it will be again a very good impression, an impressive answer for the interviewer, because that reflects your depth of understanding of all this grouping and division of machine learning models. And the better you understand, the better you'll be able to apply when a problem comes, right? So your decision basically will be depending later on what sort of algorithm you're choosing based on this understanding of yours. So the classification is goes this way, but again you can add some more as you come across. So briefly I have given here. So classifier algorithms are basically our logistic regression. Now these are classical models I'm talking about, right? Also deep learning also you can add on top of it, but which I have excluded here. So logistic regression, decision tree, random forest, gradient boosting algorithm, support vector classifier, and k nearest neighbors. These all can help you in classify various groups, okay, or for any classification problem, right? For regression, whenever you have to do regression or value prediction, you can go ahead with linear regression, or that's an algorithm. You can choose even decision tree, because now these algorithms do both dual tasks, the regression as well as classification. So decision tree, random forest, GVA, SVR, support vector regression, and KNN also. KNN comes in both of them. Sorry, it missed out here. And if you want to perform any clustering algorithm, well, there is a whole lot of varieties, but in simple, you should know at least K means PCA and agglomerative. Now, a lot of the time, it also happens candidates gets confused between K-means and KNN. Please don't do that. That could be a trap question. Very simple to know, but you should be clear. Okay, K-means comes under unsupervised modeling problem, or classifier, whereas KNN comes under supervised algorithm. So they are totally different. They work differently. Do not get confused with them. Right. So, but again, if you can, like, an idea I'm giving you, if you really want to further expand your knowledge about this algorithm, I would recommend you, before going to technical component or their architecture, if you can come up with a table about these algorithms and their comparison. What do you mean by comparison? When to use logistic regression, when to use random forest, when to use SVC. So the pros and cons of each of the algorithm, if you can come across, and if you should be very clear, then it would be really impressive answer, because that's what decides what algorithm you're choosing when a particular problem is given to you. And that's what a data scientist is expected to know in advance. uh, so because that's why the data scientist is required. Otherwise, there are a lot of tools, automated tools, anyone can use that. Nobody will hire a data scientist. But as of now these automated tools are not so sophisticated or intelligent enough to make that selection on its own, and there where the significance of data scientists does exist. So please do know them. You can Google out, you'll get this list. But if you think you are not finding, leave me a message in the comment box. I will try to share this chart for you in my next video. Let's see the fourth question. And the fourth question is difference between deep learning and machine learning. Now you can say this is very simple to say, but honestly, the interviewer, if asking you this question, would not expect you to go much into technical again, but in a layman words, you should be able to differentiate between these two. What do you mean by differentiating? That basically means you should be able to decide when to use which model. Although deep learning is a part of a machine learning, but here by machine learning, we means the set of the classical models. Okay, that's how it goes in and generally. But yeah, I think maybe in future they will do that differences. As of now, this is what it means, right? So you should be able to know what are the limitations of deep learning and what are the limitations of machine learning. When to use deep learning? Can you use deep learning in every problem? Okay, and can you, or when can you not use machine learning? So that difference is, if you can know, again, you are going to be a fantastic data scientist as per the interviewer. And the differences goes this way. These are very simple differences, but these are actually facts and you must know. So your answer should be that deep learning cannot be used everywhere. There are few technical constraints as of now till today. Okay, maybe in future the further researcher will come up with new ways of overcoming this limitation. But as of today, while I'm recording this video, deep learning has a limitation, and the limitation is that it cannot work on a small data set. Okay, deep learning do not work with a small data set. And good example I can again give you, if you are interested, I'll leave it in the description box a link where basically I'm doing a prediction of eye images. But the problem here is, okay, so this image classification is happening using deep learning. But the problem here is we have very less data set. We have just 601 images. And I can show you that the classical models are doing much better here rather than the deep learning model. But yeah, once you increase the data set, maybe the deep learning model will also do very well. So I will leave the link in the description box. You can have a look. Now let's come to the limitations of the machine learning models. So the limitation of machine learning models are these have dimensionality curves. What that means? So deep learning is expected to keep on learning more and more as you give more data. There is no upper limitation. But in the machine learning, it is found to have the upper limitation. It cannot keep on learning if you increase your data. Only to certain extent it learns, and then it gets saturated. That's the limitation of machine learning model. Another limitation, if you want to know, in machine learning models, you have to, that means when I say you, a human being have to come up with an how the design basically guide the machine, saying how it should work. what sort of equation it should form. But when it comes to deep learning, a human need not have to tell what sort of equation it should form to draw information out of the data. Rather, deep learning is much more intelligent than machine learning to do that on its own. So that's the benefit of deep learning and limitation of machine learning, right? So you're clear, right? To summarize, deep learning cannot work with small data set, whereas machine learning can work with a small data set. And the deep learning actually learns more as you give more data, but when it comes to machine learning, it gets saturated at a point and cannot keep on learning with the increase in data. So that's why we cannot make use of deep learning everywhere on every problem, and at the same time machine learning cannot solve every problem. I hope this is clear to you. Let's see the last question. The last question is types of deep learning. Again, this classification should be very much clear. Also, it's called deep learning sometimes neural networks, but overall that's what the classification is. And I'm giving you a graphical way of it. Just you can note down again, same strategy, note down and practice until you are very fluent in your answer. Tomorrow if somebody asks you this difference, that picture should come in your mind immediately. And the classification goes this way. You'll hardly find this classification on internet, but this is the actual classification, and it's so true. These are taught even in abroad or in big universities. That's how the classification does work. Okay, so overall deep learning has been all the algorithms in deep learning are segregated or grouped into two types: deterministic and generative. In deterministic, we have like fully connected architecture, or also called artificial neural network. And then we have convolutional neural network, CNN, and then we have recurring neural network, RNN, or also advanced form of it, LSTM, long short-term memory, and GRU. Okay, under generative type of algorithms, we have autoencoders and we have GAN, generative adversarial network. And there are actually some more, but it's okay. You should be comfortable with this classification. Once you are comfortable with this, later you can always add, because it's a research field. New things keeps on coming. As of now, these are finite things which have come so far. Now, what is the difference between deterministic and generative? Well, so in short, understand deterministic models works on a predefined problem set, a problem set with predefined of architecture. It can just be used for prediction, maybe a classification and prediction, let's say. But when it comes to generative models, they are versatile and they can be used not just for prediction, but even for generating new set of data. If you want to generate new set of data from learning from the current data, that new set of data can also be generated. Please understand, generative models does what deterministic does. Along with it generates, it helps you to generate more data along. Okay, so that's what the generative models does, autoencoder, generative adversarial network. Hopefully this is clear to you. Let's see the summary. So today we covered what is machine learning, types of machine learning, examples of classifier, regression, and clustering algorithms, difference between deep learning and machine learning, and finally, types of the deep learning. Just be very much comfortable and clear with these questions, and your interview will be very smooth. Hopefully, you like this video. Please like, subscribe, and hit the bell icon. And till my next video, happy learning.